Well, hello, wonderful students. So we're going to make the quick quiz video for sigma notation. All right, so we got this. We can do it. We're going to go pretty quick, but it's a lot more. Yay, that's great. That nice trend. It's a lot more about reading the notation and then just being careful with how we use it, okay? So here we go. View and copy. It'll make sense once you see it. So for those of you who came to class or worked through the lesson, you would have been introduced to this guy right here. What is the sum of the series? What? That is crazy. What do you want me to do with that? I've never seen it before. But now you have. So now you've seen it. We're going to talk about what it is. That is called sigma. What is called sigma? Precisely this right here. This Greek letter. It's the capital letter S in Greek. And we call that sigma. Sigma notation is asking you to add whatever's next. Okay, so that's kind of the general thing. So this sigma is saying, hey, it's a summation symbol. Sum up this guy 2 times j, starting at j equals 1 and stopping at j equals 5. That's what it means. The sigma notation is asking for a sum, and sum means adding. So we're just going to add each term starting at j equals 1, stopping at j equals 5. So what will that look like? 2 times 1, because that's j equals 1, plus 2 times 2, because that's j equals 2, plus 2 times 3, because that's j equals 3, boop, plus 2 times 4, because that's j equals 4, slide over, plus 2 times 5, because that's j equals 5, and we stop there. So this index down here under the sigma notation, the bottom is where you start plugging in values for j. Then notice they're integers, they're whole numbers, so we're just counting 1, 2, 3, 4, right? And the top number, the top index, tells you where to stop. So if we start at 1, we go 1, 2, 3, 4, and then we stop at 5. The top number tells you where to stop, what number to stop at. And love this. It doesn't tell you how many to do, right? It doesn't say like start at 1 and then do it 5 times. That's what happened, but that's not how it works, because you're going to have other situations where the bottom number will say like n is equal to 3 and the top is 6, and we'll see that later. So that's saying you're starting at 3, so 3, 4, 5, 6. You stop at 6, but not that you do it 6 times. Okay, think about it. Cool, so that's it. That's how you read this notation. Okay, so now how do we actually solve it? So they're asking, what is the sum of the series? This is series notation. We use the sigma. The sigma, series, and sum, they're all related. Sigma is the name of the symbol. Series is what we call it. We call this a series. And the sum is what we're going to do. It's the operation we're going to do to find. Like I said, we're going to add all that stuff up. The relationship between a series and a sequence is, let's go back. Remember how we did j is 1 and starting at 2j? It's the same thing like this. If we do our series or sequence, a sub 1 would be 2 times j, which is 2. A sub 2 is equal to 2 times 2, because that's j, which is 4, right? Because we had 2 times 1 plus 2 times 2. That's our second term if we were thinking of a sequence. Then 2 times 3. I already wrote this stuff out. That's like our third term in a sequence, not a series. Okay. 2 times 4 plus 2 times 5. So a to the 4th is 8. A to the 5th term is 10. So a sequence is related to a series in the sense that a sequence is the list of the individual terms. A series is adding those up. Add them all together. Whatever's in your list, add them. So let's do that. So now we'll have 2 plus 4, I know it's a weird 2, plus 6 plus 8 plus 10. Let's do this. 4 is 10, 2 and 8 is 10, plus 10, it's 30. We did this in class as well, so it is 30. The sum of that series is 30. No matter what variation you have, repeat that process. So if you have 3 times I, you're going to do 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4, stopping at plus 3 times 5. Add them all together, and that's how you solve question 1. That's how you read series notation. That's what the sigma means. Let's keep going. We'll keep getting that practice, okay? What is the sum of this series? Okay, each of these has a little bit of a different variation. Pay attention to where the parentheses are. This matters. Okay, we did it in class. This 3 times k squared is different than 2 times k squared because of the parentheses and where the square is attached to. Okay, in this case, you need to do 2 times k first. So starting at k equals 1, you do 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4, all of that inside the parentheses, and you'll get 120. Does that make sense? There we go. Okay, this one is different. The parentheses are not where they're supposed, or they're not the same place. That's this one. So you have 3 times k squared. So you starting at 1, stopping at 4, you plug them in. 3 times 1 squared plus 3 times 2 squared plus 3 times 3 squared plus 3 times 4 squared. You are welcome to use a calculator. In fact, I would. Okay. And then finally, this variation. Okay, that's all written out. Aha. So look, this is, oh no, this one is different. This one is different. We'll look at a different one. So how would you do this one? Again, you're just going to start at 1 and you're going to each time plug it in. So you'll have 2 times 1 squared minus 4. That's that one. Plus 2 times 2 squared minus 4, and so forth. Find each of those values, add them up. What is the sum? And you're good to go. You're welcome to use a calculator. You are welcome to use a calculator. But again, start at 1, 2, 3, stop at 4, substitute it in for k each time, and then add them together. Okay. Question 3. Here we go. Variation 3. Okay, let's see what's variation 4. Variation 1. All right, let's do variation 1. It doesn't really matter. They're all very similar. You're going to have an expression in front of your sigma. Look at the bottom. What number is that? That's a 3. That's where you're going to start. K equals 3. Exactly what it sounds like. K equals 3, so just substitute in 3. But then the sigma notation, the way we know how to use it, okay, we'll start at 3. Then we'll just use counting numbers. So we'll go from 3 to 4 to 5 to 6. I'll show you in the calculator because I think that's the one I already did. But how does this work? How do we read this? How do we expand it? Well, we'll start at 3. So we'll have negative 2 times 3 plus 5. That's k equals 3 plus negative 2 times 4 plus 5 plus negative 2 times 5 plus 5 plus negative 2 times 6. We're going to stop here from 3 to 6. Start at 3, 4, 5. Stop at 6. K equals 6 plus 5. That's a 5. Now we evaluate. So that's negative 6. You can use a calculator, though. Negative 2 times 3. That's going to be negative 1 plus negative 8 plus 5. That's negative 3 plus negative 5 plus negative 7. Yeah. And then look at this. Yeah. There's a common difference of minus 2. Minus 2. This is an arithmetic sequence. So this is an arithmetic series. The list of numbers is the sequence. The summation is the series. So now we're going to add it up. We have -1 plus -3 gets us -4 plus -5 gets us -9 plus -7 gets us -16. But remember, like you saw, let's type it into the calculator so I can show you that skill. Okay. Okay, no, it's a different one. So now I'm going to type in parentheses -2 times k plus 5, close parentheses, and a plus sign. Okay, so this is my original explicit formula. I am lazy, so I take it. This is just what I do. I copy it, I paste it, 3, 4, 5, 6, and then I go replace the values. So k equals 1, k equals 2, k equals 3, k equals 3 because we're starting at 3. K equals 4, k equals 5, k equals 6. We can stop because we're stopping at 6. -16. I think that's what I said. But if I didn't, that's okay. I use a calculator to check my work. That's smart. That's what we should always do. Okay. All right, here we go. Scrolling down. Nope, we're not scrolling down. -16. If you have that variation. If you have a different variation, it's just a matter of substituting in your k values and evaluating, boom, 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 and then adding all of that together. Hopefully that makes sense. And you at least get 60%. All right, here you guys should get these as well. Questions 4 and questions 5 on quiz 404. They're going to have you work backwards, but you've already done it. You've already done it. What they're going to give you is a list of numbers being added together. Well, if you replace the plus sign with a comma, you now just have a list of numbers, which is a sequence. And you already did great on the sequence quizzes, most of you. And if you didn't, that's all right. Let's see if this helps clear it up. So you have an explicit formula that you can use to check. But we also had a classmate who showed a great skill, and that skill was guess and check or substitution. I'll show you this. So let's take a look at this one right here. We have, all right, that's pretty good. How is it changing? So if we just, like I said, made this a list of numbers and thought of it as a sequence, 1, 1/2, 1/4, 1/8, 1/16. Is it geometric? Is it arithmetic? Is it changing by a common ratio, something that's multiplying, multiplying, multiplying? Or is it changing by a common difference, something being added or subtracted, added or subtracted, added or subtracted? We can check it. The first one, you do 1/2 minus 1. That's for the common difference to see if there's a common difference. 1/2 minus 1, right? Take a term, subtract the prior term. That's -1/2. Okay, let's do it for the next one. Let's take 1/4 minus 1/2. Well, that would be 2/4. So that's actually negative, right? This would be -2/4 because 1/2 equivalent. That would be -1/4. So no, already we can see it's not a common difference. That's just how you can check. Hopefully you see that it's changing by a common ratio. So this shows it's not true. So it's not arithmetic of a half. Let's try it. So let's try 1/2, the second term, divided by the previous term, which is the first term. That's 1/2. Okay, let's check another one. Let's do 1/4 divided by the previous term, which is 1/2. We're checking for a common ratio. 1/4, that indeed is going to be 1/4 divided by 1/2. It's the same as multiplying by the reciprocal. So we get 2/4 and boom, 2/4 simplifies to 1/2. So that's the explicit way of trying to check for that common ratio, right? And then let's just look at it. 1/2 times 1 times 1/2 is a half. 1/2 times 1/2 is a fourth. 1/4 times a half is 1/8. So the common ratio is 1/2. Great. From that, we can figure out our series notation, our sigma notation. 1, 2, 3, 4, 5, 6, 7. We're stopping after 7. We're going to start at 1. Let's say it's J. I think it is J. Now, our explicit formula for a geometric series, a sub n, is equal to the first term, a sub 1, times the common ratio raised to the n minus 1. The n doesn't matter. It's just the index letter. So in this case, it would be a j. So this we would write a sub j, it's fine, is equal to a sub 1 times r to the j minus 1. So whatever letter they have, K, L, Q, R, doesn't matter. That's just a variable as a placeholder for your series notation. All right, so what's our first term? It's 1, so 1 times, what's our common ratio? 1/2. What is our index? J minus 1, because that's the explicit formula. That's the explicit formula. Let's go take a look. Nice. Okay, so another thing you could do is if you wanted to, you could just start plugging in 1, 2, 3, 4 into these and see if it gives you each of these terms. Right here, we already know it's wrong. If we plug in 1, we'll get 1/2, and that's not right. Over here, if we plug in 1, we do get 1. But if we plug in 2, we would get 2 for the second term. You have to do the math if you don't understand what I'm saying. Over here, this is the correct one. We will get the correct series, the correct sequence if we listed the numbers. And then down here, 1, you get 1. So 1 plus 1 is 2. 2 times 1/2 is 1. But then when 2, you'd get 2 plus 1, or 1, which is 3, 3/2. And 1/2 is not the same as 3/2. So you can check it like that. Test taking skills are important. You're never going to get away from tests for better or for worse. You are more than a test score, but you won't get away from it, okay? All right, let me pause real quick. Okay, so down here, here we go. We already got it. So let's just talk about this last question for quiz 404. Hopefully you're seeing -7, -2, +3, +8, +13. How is it changing? Is there something being multiplied, divided, added, subtracted? And hopefully you're starting to see that if you look at the individual terms in between the plus signs. So that's what you're looking at here to kind of go backwards. You could also do what our classmates suggested, which is just start plugging in 1 and see what you get. So let's just start with this one right here. If I plug in J equals 1, I get -8 times 1 plus 1. Well, that's -8 plus 1. That's -7. Okay, that's a good candidate. Let's do next. -8 for J equals 2 times 2 plus 1. It's -16 plus 1. That's -15. Nope. The next one we need is -2, so it's not this one. Let's just plug in 3, because if when J equals 3, right, J equals 1, should be -7. J equals 2 should be -2. J equals 3 should be 3. 1, 2, 3. See if that makes sense. So let's plug that in for this one. So we have 5, 3 minus 1. That's 5 squared. That's 25. No. So these are the terms J equals 1, J equals 2, J equals 3. So now to kind of check them, I just picked J equals 3, substituted that in, and I got 25, which is not 3, so no. Okay, let's check this last one with J equals 3. So we're looking for the third term is 3. So then for J equals 3, we should get -5 times 1/5 to the 3 minus 1, which is -5 to the 1/5 squared, which is 5 times 1/25, which is going to be 5/25, which goes back down to 1/5, and that's not right. So by plugging in and just checking, we did it that way. So you can always do that. Let's talk about why this is the correct answer, though, using the formula method. Hopefully you kind of notice there's a common difference. So from -7 to -2, there's +5. From 2 to -2 to +3 is +5. From 3 to 8 is +5. From 8 to 13 is +5, the common difference. Make sure you have that down. Our book gives us this, where you do A sub n is equal to A sub 1 plus n minus 1 times d. We can use J. I could have used J. Sorry, let's do that really quickly. Because A sub J is what our index letter is, and it doesn't really matter. A sub 1 plus J minus 1 times D. So let's distribute. let's substitute in and then we'll distribute. So we have a sub 1 is negative 7 plus j minus 1 times 5, because that's our common difference. Now let's distribute. So we'll get negative 7 plus 5 times j minus 5. Okay, so here's our 5j. Boom. Our negative 12 comes from negative 7 minus 5. We combine like terms, and that's where our negative 12 comes from. All right, you guys, thank you so much for watching. If you rearrange that formula for an arithmetic sequence, you will get the explicit formula that looks like this. The common difference times n plus your first term minus your common difference. I like this formula better. It's pretty quick. It's a lot quicker because look, our common difference, let's just use j. It would be 5 times j. And then our first term would be negative 7 minus 5, our common difference. And that's negative 12, where really this one's closer. So up to you. It's from the same exact formula from your book. I just rearranged it using the powers of algebra. Keep thinking about it. Love all of your guys' strategies and your suggestions. Thank you so much for your great participation.